This section of the final exam review is going to be on lipids. And what I want to start with is the categories of lipids. Within the categories of lipids, we have fat, our most well-known lipid, sterols, and phospholipids. Now remember, sterols, which is cholesterol, is a sterol, is a lipid, while fat is a lipid. But cholesterol is not a fat. Fat is not a phospholipid. So these are all types of lipids. Let's start with fat. And the fat that we know the best is called a triglyceride. So that's 3 fatty acids attached to a glycerol backbone. This is the type of fat that we consume. It's also the type of fat that we store on our bodies. So it's the consumed fat and the stored fat. Sterols, and our most well-known sterol is cholesterol, serves as many functions. Cholesterol, in particular, is part of our cell membranes, our nerve sheaths. This is how we synthesize bile, hormones, and in particular, vitamin D. Lastly, we have phospholipids. These act as emulsifiers, and they are also part of the lipid bilayer in the cell membrane. An emulsifier, for example, lecithin, which you'll see added to foods in many food products, is simply something that can bring both fat and water, or an aqueous environment, together. For our fats, and these are in particular fatty acids, we have 3 main types. Our saturated fat, which means that it's saturated with hydrogen. There are no double bonds. Monounsaturated, which means there's 1 point of unsaturation. Essentially, there's 1 double bond. And polyunsaturated, which means that there are 2 points of unsaturation, and at least 2 double bonds. The other type of fatty acid is a trans fatty acid. This does occur in nature, but to a very small extent. Most trans fats are formed through a hydrogenation process. Manufacturers will start with an unsaturated fatty acid. Under pressure, they will add hydrogen. This will form either a trans fatty acid or a saturated fatty acid. Notice how they're both very similar in structure in this image. So even though there is a double bond, it's as if it's flipped. So again, structure actually helps determine function. We'll talk about this more, and it's more important when we talk about proteins. Manufacturers make trans fats because they want a fatty acid that is more stable. So a saturated fat is more stable than an unsaturated fat. It's going to go rancid less quickly. You can't use a lot of monounsaturated fatty acids on the shelf in food products because they're going to go rancid. So you make them into a trans fat. So if you see hydrogenated cottonseed oil, hydrogenated soybean oil, you know that you have a trans fat. So whatever vegetable oil that they have is now a trans fat. And this is going to be a more stable form. It'll help prolong the shelf life. One more thing, I need to go back. We talked a lot about trans fats through our discussion, but remember that trans fatty acids are associated with an increased risk of chronic disease, in particular heart disease. They're much more deadly than, say, what most people think of as saturated fats. So trans fatty acids are associated with detrimental health effects. So partially hydrogenated oil is generally going to give you a trans fat, even if it doesn't say, even if it has 0 listed on the label under trans fats. Now, going back to our unsaturated fatty acids, we have our essential fatty acids. Now, you're going to be asked on the final exam that which type of fatty acids are essential fatty acids. Well, it's the polyunsaturated fatty acids, which give us our omega-3 and our omega-6 fatty acids. Those are our essential fatty acids. Omega-3 fatty acids have numerous health benefits. The ones I want you to know for the exam are going to be to decrease clotting and decreasing inflammation, which then will decrease the risk of heart disease. We want a balance of omega-3s and omega-6s in our diet. Unfortunately, most Americans have too many omega-6 fatty acids, too little omega-3 fatty acids. This increases the risk of inflammation, clotting, heart disease, but also most chronic diseases. Remember, omega-6 fatty acids occur with the most vegetable oils. So when you start, particularly things like soybean oil. So all of those oils that you see in processed foods, the vegetable oils, are generally going to be the omega-6 fatty acids. And that's why most people are taking in too many omega-6 fatty acids. It's generally not because they're consuming too many walnuts, which have omega-3s, but are usually generally very high in omega-6 fatty acids as well. Omega-6 fatty acids can be increased by eating fatty fish or eating things like flaxseed or chia seed. The dietary guidelines recommend 20 to 35% of total calories from fat. So yes, a third of your diet should be coming from fat. Unless you have a chronic disease or heart disease, then it should be much, much less. Saturated fat should be less than 10%, although the American Heart Association says less than 7% from saturated fat. We did talk about potential benefits of saturated fat this semester. Remember, this is still a controversial topic. Trans fat, pretty much as little as possible, less than 1%. There is no reason you should ever have trans fats in your diet. There's no health benefit from that. Omega-3 and omega-6 fatty acids, those are both our essential fatty acids, meaning essential. We need them from our diet for health. And then cholesterol should be less than 300 milligrams. We're going to finish up with talking about lipoproteins. Remember that LDL and HDL are known as cholesterol, but they're not actually cholesterol. They are lipoproteins. I still want you to know that LDL is known as the bad cholesterol, while HDL is known as the good cholesterol. But you also should know that in reality, they are really a lipid protein carrier. So they're carriers of cholesterol and triglycerides. A high LDL has been associated with the increased heart disease risk, especially that small, dense LDL. High HDL has a decreased risk of heart disease. That'll be the end of this section on lipids.